this module, we're going to continue to work with the gradebook that we created in the last video module. And here inside of Visual Studio, I want to point out some features that relate to creating and using other assemblies. First of all, we know now that when I do a build in Visual Studio, all of my source code files, all of the .cs files will be collected together and built into an assembly. And we can find that assembly if we go to the location where we stored this project on disk and open up a command prompt. The compiler by default will build an assembly into the bin for binaries debug directory. And inside of here, if I list the files, I told you before there's a number of files in here that are related to just debugging information, but grades.exe, that is the assembly that the C# compiler produced, and that is an assembly that I can run because it's an executable, and it prints out statistical information about the grades that I've entered into the gradebook. Now, what rules does the C# compiler use to produce grades.exe? Why does it pick that name? Why does it pick that extension .exe? I'm going to right-click on the project node, Grades, and go to Properties. And under Properties, I want to go to the Application tab. Now, back in the last module, when we created this project with File New Project, I told Visual Studio that I wanted to create a console application named Grades. So by default, Visual Studio just configured a number of settings for me. For example, it configured the assembly name to have the same name as my project. So the assembly name is going to be Grades. But how does Visual Studio and the C# compiler then know whether to put on a .exe or a .dll extension? The extension is controlled by this output type setting. It's in here where I can select if I want this to be an application, console application, or Windows application. A Windows application would be an application that puts up Windows on the screen. Since we're running this from the command line, we have console application selected, but I just want to show you what would happen if I selected class library instead. A class library produces a DLL. And if I build this project and I come back out to the console window, let's do a directory again, and now I can see I have grades.dll. Unfortunately, grades.dll is not something that I can execute. Windows will give me an error and says it doesn't know what to do with this .dll file. I would get the same sort of error if I came into Visual Studio and tried to run this with the debugger or even without the debugger. Visual Studio will tell me a project with an output type of class library cannot be started directly. So a dynamic length library that is a .dll file, or what we would more commonly call inside of Visual Studio a class library, that is an assembly, but it's not an assembly that can execute directly. It has to be loaded into some other program which will use the classes inside of that DLL to do work. So let me come back and change this back to being a console application. And then if I try to run with or without the debugger, Visual Studio will rebuild that project, and I have a working executable again. So grades.exe is again an assembly that I have on disk that I can execute directly. And this is not the only assembly involved in the execution of this program. I'm also relying on other assemblies like mscorelib to give me classes like console and math. We used the math class in the last module to help compute some of our statistics like highest grade and lowest grade. That was inside of gradebook.cs. Here you can see I'm using the math type. Whenever you're using a class from the .NET framework or really any other third-party assembly, you can always place the cursor on the name of that class and press the F12 key. What Visual Studio will do is open up an editor window with what looks like the source code to that particular class. It's not really the full source code. Visual Studio is just trying to show you what's available on the math class. And here I can see there's methods to call to get an absolute number and an arctangent and a logarithm. What I just want to point out here is at the very top of the file, Visual Studio will tell me what assembly this type lives in. So the math class that has static methods we can invoke directly, it lives in the assembly mscorelib. And if I want to see all of the assemblies that I might be using during the execution of my program, I can come into the Solution Explorer window and open this References node. All of the little block icons in here are specifying the names of other assemblies that my project references. So there's a couple things to note here. One, by default, when you create a new project with Visual Studio will give you a number of assembly references. These are common assemblies that many applications use, but our application doesn't actually use all of the assemblies that are listed here. And that's okay. It's not an error to reference an assembly that you don't use. In fact, there may not even be a performance overhead to that because .NET will only load an assembly when you actually start to use a class from that assembly inside of a program. But an assembly like system.net.http, that's an assembly that I could use to make calls over the network using the HTTP protocol. It's not something that my program actually does. I can right-click this assembly and remove, and I'll still be able to build the program and everything works. If you remove an assembly that has a class that you are using, you will get a build error. Now, one assembly that you might notice is not here is MS-CoreLib. And that's because MS-CoreLib is such an essential assembly that nearly every .NET application has to have that Visual Studio doesn't even list that assembly in the references. It's just implied that you'll be using MS-CoreLib. Now, one additional feature that I want to point out is quite often you'll want to be able to see what is inside of an assembly. You just want to be able to explore and see what classes might be available. That's the job of the object browser. So if I come to the View menu, one of the options here will be the object browser window. There's actually a couple ways to open this. I can get to it from the View menu. I can also right-click an assembly over here and say View an Object Browser. That will open the object browser and put the focus right on that assembly inside of the object browser. So the object browser allows you to look through all of the namespaces and all of the types that are inside of an assembly. So I can see here's my grades assembly. What's inside of my grades assembly? There is a grades namespace. And inside of that namespace, I have three classes. The gradebook class and the grade statistics and the program classes, those are all classes that we implemented. And what's inside of MS-CoreLib? Inside of MS-CoreLib, you'll find dozens of namespaces. And inside of each namespace can be dozens, maybe even over 100 different types. So here inside of MS-CoreLib, inside of the system namespace, this is where I will find classes like console. And if I click on console, the object browser goes one step further. Over here on the right-hand side, I can see all of the methods that are available on that console class. So I can see there is a read line, which is a method we used in the first module of this course to read a user's name and find out how much sleep they had the previous evening. Also inside of here would be the math class. So that's another way I could look and explore what can I do with this math class that is in MS-CoreLib. Now, so far, inside of our grades program, we haven't needed any classes from assemblies that we don't have referenced. That is, when Visual Studio set up this project, it gave us access to all of the classes that we'd ever need for this gradebook. Most of the things that we use are in MS-CoreLib or in System. But in the next clip, let's try something a little bit different and see what we have to do if we need to use a class that is in an assembly that we don't currently have referenced.